So what is work? In physics and engineering, of course, work has a different connotation than in civilian life, but work is the change in energy in a system. And energy. So we can write that as work equals change in energy. Now that energy can be mechanical, like I'm pushing something down the road, or lifting something up and giving it potential energy. That can be something like charging a battery. So if I'm putting electricity into a battery, there's change of energy, so work is being done. It can be burning petrol. We had a lot of energy in the petrol tank. We burn the petrol. We have less energy, so therefore work is done. In a purely mechanical sense, work is equal to force times distance. Force is of course measured in newtons. Distance is measured in meters, and work is going to be measured in joules. That's joule, named after the French physicist of the same name. Now this is a purely mechanical thing. The force and distance must be in the same direction. So what we can do, three students push a car with force 600 newtons for 20 meters. So say we've got three students and they're pushing a car. Let's draw a picture, write down what we know. Force is equal to 600 newtons. D is equal to 20 meters. So work, because the force is going this way and the distance is this way, in the same plane, work equals force times distance equals 600 newtons times 20 meters equals, what's that, 12,000 joules, or 12 kilojoules. Another example, two students use a pulley system to raise a 300 kg piano 5 meters. So they're lifting up a piano over the pulley, students. How much work are they going? Again, force is equal to 500 newtons. Oh, sorry, yep. Well, force is going to equal mass times gravity, which is equal to 500 kg. I'm going to use 10 meters per second squared as the value here, equals 5,000 newtons. So force equals 5,000 newtons. Distance, sorry, how much is the piano? 300 kg. 300 kg equals 3,000 newtons. Distance equals 5 meters. Force is equal to, work is equal to force times distance, equal to 3,000 newtons times 5 meters equals 15,000 joules. Let's do another couple more examples, just because we can. So, what happens though if the force is not being applied directly? But say a boy, or a girl, doesn't matter, pulls a box Force equals 200 newtons for 15 meters. If the rope is at 30 degrees from the horizontal, how much work is done? This is more difficult than the other one. So what we have here, we draw a picture, we have a box, we have a rope, we have a person, a little kid, pulling the rope at 30 degrees, and they're pulling with 200 newtons. Now the question is, work equals force times distance, but the force has to be in the same direction. This force is actually going up there. So how can we work this out? What we have to do is we have to work out, sorry, wrong colour. We have to work out the x component, force x. So force x is going to equal the force cos theta, because we're trying to find this component which is adjacent to there, force cos theta. So what we can actually do to work out the force here, because this is such, we can actually substitute this in. So work equals force times distance cos theta, and this is a general form of the equation. So if we've got this, we can now work out how much is moving along in the same direction as the motion. So D, force equals 200 newtons, distance equals 15 meters. So we need to work that out. So work is equal to 200 newtons, distance is 15 meters, the cos 30 degrees, calculated time, so it's going to be 3,000, 200 times 15 is 3,000 times cos 30 equals 2,598 joules of work. Cool. So when we're pulling along, it's not on the horizontal. We have to take into account how much force component is shifting that way. And to do that, in this case, we measure from that angle and we can use cos. Woo, done.